Hi, my name is Claire. This is the presentation I have for EDF5173 Assignment 2. So in this presentation, I'm going to focus on the photoelectric effect from VCE physics curriculum. As a foundation to modern physics, the photoelectric effect is one of the hardest content for most of the students, and there are countless alternate conceptions that might appear during the study. So first, let's talk about what I expect students to know about this topic. We'll start from looking into the study design. So we see Study Design 2020 described several key learning objectives of photoelectric effect for high school students, focusing on the experimental evidence and the interpretation of those evidence to achieve the understanding of the particle nature of light. The study design mentions several aspects as shown below, such as the students need to identify the kinetic energy of the photoelectrons and understanding the effect of the intensity. However, as a former student and pre-service teacher myself, reading this didn't help my confusions very much. So to simplify the learning objectives, I would describe my expectation to my students as following. So the whole photoelectric effect is formed around this central formula. The energy input from the photon equals work function plus the kinetic energy. So when the light hit a metal surface, the energy input from the light will have two functions. One is the work function, which is an energy that required to eject the photoelectron, and the other one is the kinetic energy of the ejected photoelectrons. Based on this idea, students need to understand and identify 5 fundamental properties of the photoelectric effect, which are light intensity, stopping voltage, threshold frequency, work function, and maximum kinetic energy. In addition to their separate properties, students are also required to understand the frequency, understand and explain the relationship between them. For example, between the color of the light, which is the threshold frequency, with the stopping voltage, as well as the relationship between the light intensity and photocurrent, the kinetic energy and the input frequency, and those relationships are often introduced in the graphs of the experimental data. So in general, students are required to explain how does the photoelectric effect support the particle mode of the light. To achieve this, students need to develop a full understanding between the wave model of light and the particle model of light, and interpret those experimental data in aspects such as the negligible time delay, the existence of a threshold frequency, and the independence of stopping voltage to intensity. As mentioned before, as one of the most complex concepts introduced in physics, there are many alternate conceptions and confusions students might have. One of the most popular alternate conception is the confusion around light intensity with energy, that the light intensity of the light affects the energy of photons or the energy of a photoelectron. This might be because that from students' experience, they tend to relate larger intensities to larger energy, and they might be like the experience of light as particles. It is hard for students to relate light intensity to the number of particles if they don't have the idea of the photons. The second alternate conception is related to the confusion between the photons and electrons. Some students might think photon as a charged object and Ohm's law is responsible for the photoelectric effect. This might be because some students intend to relate this concept with a more familiar concept to them, which is electron. Another alternate conception is the number of photoelectrons depends on the energy of the photon. Students holding this alternate conception might think that one photon can interact with more than one electron, and hence eject more photoelectrons. They should grasp the idea of one-to-one corresponding relationship between the photons and the electron, that one photon is completely absorbed by one single electron ejected from the metal by imparting all the energy. And this absorption is an all or nothing process. The following alternate conception is related to the nature of photoelectric effect, that some students conceive the photoelectric effect as being a result of the ionization of atoms through the interaction with light. The main reason for this existence of this alternate conception is teaching energy levels in the Bohr model of the atoms. The Bohr model of the atom is so powerful and rooted deeply in students' mind that the concept of ionization is the first thing coming to learners' mind in considering any quantum phenomenon. And during our teaching, we shouldn't erase the model in students' mind completely, but conveying the conscious of use the model in order to let them have a degree of insight into the model's limitations. And for the interactive artifact, let me show you this program, which I obtained from the web link below. But you do need to download it to run. You can't run it on the web page. So let me stop sharing my screen and start sharing the artifact. As shown here in this simulation, there are 4 factors we can manipulate: the intensity of the light, the color or the frequency of the light, the battery voltage, and the material of the target. We can manipulate any of them and show the impact of that to the photo current to students. And we can also plot several relationships in the experimental data, like here. For example, if I want to show my student how to generate and how to compare the stopping voltage of different color of light, we can set the intensity to maximum. We fix 1 target materials. As we can see that from 0 voltage, there are some photons can reach the cathode. Then we can start to move the battery from left to right, right to left, and see to which point the photons stop, the photoelectrons stop reaching the other side of stop reaching the receptor. And we can see from the graph here, the plot the current versus battery voltage. We can take a photo and check on the data on there and see where is the photo, like the stopping voltage. We can even enlarge the data. So if I want to check with another color, I can just change the color here, repeat the whole process, and generate a new data and compare the data from the graph. A small inconvenience of this simulation is that you can't compare 2 lights in 1 graph. You have to generate the data separately, take a photo, then compare the data on the photo. We can not only use this simulation in class, but also give the link to our students and let them play with it. We can even use this simulation for practical investigation and let students explore the relationship between the 2 features of photoelectric effect. As we all know that the practical investigation of photoelectric effect is really hard to observe in the classroom or in the lab. So this simulation will be a great tool for that. The student can pick their favorite 2 relationships and 2 features and explore the relationship between them. Cool. Let's go back to the presentation then. So in conclusion, photoelectric effect is a complex conception that students might have difficulties in understanding the new mode of light and have many alternate conceptions. But these difficulties can be overcome with the help of many modern technologies, multimedia presentations, and hands-on practical investigation. And that's the end of the presentation. Thanks for listening.